Hello and welcome to this tutorial on asteroids. So first things first, there's a couple fonts here. I didn't use it, but there's a font that's sort of an asteroids font. And then there's the sprite. So you can bring those into your game. The other thing we should do right at the start is get our camera set up. So set that background to black. And also in your game, just make sure we've got a 16 by 10 so we can build it for the web with no problems. And there we go. So first of all, let's get our player here. So I'm going to go into my sprites and we should have the player and we can drag not into the scene, but into, or not in the game I said, but into the scene there. And I would suggest making that a little bit smaller. If we take a look at the game there, it's a little large, but you know, this is something you can tweak to your preferences. I'm going to just cut everything down to 0.5 there. You could possibly go down to 0.25. And then we're just going to add some, add some components here. One thing we'll do is we'll add the rigid body. Make sure that's on there. We'll add a box collider as well. Just turn off gravity. We'll talk about the drag and stuff when we get into that a little bit more. And then box collider, we'll just use a box collider. That's close enough. And you might want to just sort of, I'd suggest reducing it a little bit. So you got a little bit of the edges and the tip, sort of the, you know, the tip and the corners, I guess really is what I'm trying to say. Make that a little bit smaller. So maybe, you know, 0.8 or something. Again, you can test and modify it, but it just sort of, you know, it makes it feel like you're actually getting hit, right? More of a, oh, that was close kind of thing. So there's our player. And really that's all we need. So we've got our rigid body and our box collider. So we might as well go ahead and make a script to get this moving. So I'm going to just create a new folder and scripts. And we'll use the old C# script. We'll use the old input system. No new input system here. And we'll just call this player, if I can spell it right. And we'll hopefully open up Visual Studio. So the script here, we have to put in a few variables here. So let's put in a couple private ones to begin here. A bool, and we'll call that sort of thrusting. So if it's thrusting or not, because basically we only have really forward power and then sort of, you know, turning left and right. And the other thing there, just like I said, basically the turn direction. So we'll have that in a float. And what else here? Let's set up two public ones just in case we want to modify this somewhere else. Thrust speed. And we'll set that, we'll just set it to a value of 1 to start with, but we can always change that. And public turn speed, public float turn speed. And we'll set that to 1F as well. The other thing we'll set up for a rigid body, public, so rigid body, all these old stuff that we're used to, body 2D, and we'll call that RB2D. And just thinking, I think that's probably good for now. So down in the start, let's grab our rigid body component. So RB2D, there, everything's there, perfect. And then we'll get into our gathering our inputs. And so I said, we'll use the old style input here. So what the thrusting will be, it'll be equal to our keys. And depending on what you want to do, dot get key, dot get key. And then the key code, we can do W. Again, this is a little bit up to you. Or we can do the up arrow. So input.get key, and we'll just do that key code, and we'll make that the up arrow. Okay, so we've got those two. That would be basically setting thrusting on or off. And so we did set that as a Boolean, basically. And so if you are pressing it, that's going to set it to either, well, to set it to be true. Okay. And then we've got our turn direction. So let's just go in here. This one we need a little bit more. So we've got an if. Basically, I'm just going to copy this because I think by the time I type it in, we're just going to change the keys here. So to turn left will be that or the left arrow. And I think we might have an extra bracket there then now. Okay, good. Yep. So if we turn to the left, our turn direction will be +1, which seems a little bit odd, but don't worry, it works. And then basically else if, and I'm just going to copy that, else if, I think I'll just paste that in again. And then so this will be our D and our right arrow. And then we'll just fix up the brackets. And then basically it's the same. Fix my else if here, and our turn direction will just be -0. Or -1. Okay, it's a Friday night here, and I'm doing this. Okay, so that should do that. I don't know. I guess we do need that parenthesis. Now that I look at it, because we got to close that up. I don't know, we're getting an error before there, but that looks good now. Okay, no errors. We are good to go. So then the other thing is if we're not pressing anything, we should set that turn direction. So we'll put an else in here, and we'll set that turn direction to 0, just like it suggested. Turn direction is equal to 0. We will for now, well, yeah, we'll leave the shooting for later. So that basically gets all of our inputs into the computer, and then we just need to push it. And so that should go into our fixed update. And there we go. There we go, perfect. And so here we want to actually get it to move. So if the thrusting is true, okay, so if we do have that key being pressed down, and so like I said, we're not getting any value out of it. We're just basically setting is it being pressed or not pressed? Then what we'll do is RB2D. We're going to grab the rigid body. We're going to add force just like we've done before. And this game object, so we're talking about the player here, transform.up. So that will be pushing it forward, and then we'll just multiply that by the thrust speed. Okay, and so once that is there, we should be able to move forward at least, and then we just have to set the turn direction. So again, another if here. So if the turn direction, now we've got greater than 0 here, we'll make that, if it's not 0, then we're going to turn. So I will take that. So we're going to add torque, which is basically to spin it. So RB2D dot add torque, and we're going to spin it basically around its axis. But so this will be fine here. We just do the turn direction times that variable, the turn speed. There we go. So that should be enough to get it moving across the screen. So I'm going to hit save there. We don't seem to have any errors. And I will go back into Unity. And hopefully we can apply our player script. We've got those base numbers there. And just see if he moves. So he is moving, spinning a little bit too much, but spinning away too much. But he is moving. Okay, that's good to know. So I think the thrust seemed a little bit low, maybe the turn speed a little bit high, a lot high. This is where you can play around with the drag a little bit to get you what you think would be right. I think basically, yeah, I mean, that's not bad. It's a little bit, again, a little bit spinny. Obviously, I go off the screen here very quickly. We will implement a screen wrap later on. I think some more linear drag would be helpful, but you can see it's working pretty well. If I want to go backwards, it's always a little tricky here. It's a little bit finicky, but as I go shooting off, but it's working there. All right, let's actually get the shot working too, if we can. We'll see how much we can get done here. So I'm going to bring in the shot. So we'll set that up at least. So I do have just a square, which is going to be our shot. Should probably rename it. A little big. So I think this one I did like 0.075 or something. So, whoops, not 75, but 0.75, just to make it pretty small. Again, you might even go smaller than that now that I look at that. Maybe 5 on that. Depends on your original scale, right? You're just going to make them to scale. So maybe something like that. That's not too bad. This little guy too, he's moving, so he'll need a rigid body and a box collider. Let's just do the box collider first because it's right there. I think I'll leave it as it is, and then I'll just add the rigid body 2D. Okay. Oh, I put a box collider, not a box collider 2D. Mr. Fleming. Okay, remove component. Box collider. Okay, now I'm going to do the rigid body 2D. And then we'll add the box collider 2D. There we go, box collider 2D. We're good. Okay, so those should be good. And then we can basically create a shot script as well. So I'm going to go back into my scripts and create a C# script, and we'll call this shot, and we'll open that up. So the shot one's going to be a pretty straightforward script, even easier than, well, it's going to have less than the player script in it, because really it just needs to move forward here. All right, so we will put a few things at the top. We do need the rigid body, so public rigid body 2D, and we can call that RB2D as well. We're going to have a couple things. We'll call it public float speed. And again, we'll initialize that to 1F. I tend to do that now because then it prevents us from forgetting that it's 0 and then it not moving. And we will destroy it as well. So we will public float max life. So basically how long it's going to learn. My mummy sending me emails. Okay, 1F. There we go. And yeah, we should be good there. And so then in our, yeah, the other one before, I should probably get in the habit of making this one awake, because that happens even before the start. So just grabbing that rigid body, just like that. We will get the screen bounds later on. And then what we're going to create is we'll get rid of the update here. We're going to create a project, and we'll make this public so we can actually call it from the, we're going to call it from the ship, right, from the player script. So we'll get to that in a little bit here, but we're just going to do the project, and it's going to pass, so void, sorry, public void, we're going to call this project. You could call it fire, shoot, whatever. And what it has to do is it has to pass in a direction, because we want this shot to go in a specific direction. We don't always want it to go forward or up or whatever. It needs to go in a specific spot. Sorry, direction. Okay, didn't seem to want to get off that. Okay, and then so what we'll do here, RB2D dot velocity, and then, sorry, no, that's not what we want. RB2D, and then we'll put in here, sorry, RB2D dot add force, and then we're going to do the direction times the speed. So direction times the speed, and after that we will simply put on, we'll destroy it, and we'll destroy itself. So this dot game object, and we'll do it for that time that we set, so the max life. So that will automatically destroy it after a certain period of time. Good. So that's looking pretty good there. Just make sure there's no problems. Okay. So next we should have to go back to the player and get it to fire. All right. So back in Unity here, let's change the name of the square to shot. And we might as well turn off the drag here. So this just makes that 0. And then we might as well drag the script on as well. Oops. Now we're going to make that into a prefab in a second here. There, so everything looks good. Let's just make a folder here for prefabs. Prefab. There we go. And I'm just going to drag the shot in. And I might as well at the time just delete this shot because we won't want a shot right at this beginning. Now the only reason that we're going to have a shot is when we instantiate the shot by the player. So we have to do a little bit more here on the player script to get that to work. So let's go back to the player script. And we'll come up to the top because we're going to put in a couple, one or two variables here. Yeah, one is the public shot, and that's going to be the shot prefab. We'll call it shot prefab. So that should be good there. Don't think we need anything else. And then down in here, so in terms of our controls, we're going to have to put in one as well. So I'm going to use the keyboard here, or sorry, the keyboard obviously, but I'm going to use the spacebar for this. So if input.get key down, I'm going to use get key down here because I want them to mash this board multiple times to actually get it to fire. I don't want it to continuously fire. So that's a input get, like the get key down requires a full down and up before it will fire again. And we're going to run the shoot function. And we haven't created the shoot function here, but we will do that in a second. So we will come down. Let's just put it under fixed update here. And this will be private as code. So public shoot. It won't take anything. So it's just quite a simple little function. And in here, actually, do I need it to be public? I don't think I do. I'll just leave it as is now. Maybe just explicitly we'll say private. And then on here, so shot, of the type shot, we'll call it shot. And we're going to instantiate. So that means we're going to create it. And it's going to be what? We're going to create the shot prefab. And we have to create it here. Transform.position. And then we're also going to do transform.rotation. And so that will just sort of bring it in. And then we have to projectile it. We have to make it move. So it'll be shot.project. And then it will be transform.up. So it'll be shooting it from that position. So remember before we had created the project function. And so now we're passing in the direction, and it's the direction of the player. It's the up position or up direction of the player. Okay. So I think that's all we need here. Let's take a look. I'm going to save this. We've got the shot and that. So now when I go back into Unity, we should be able to go to the player, and we should see the shot prefab. So we should be able to drag our shot prefab in there. Hit play. And then hope when we hit the fire. So it's kind of working. Okay, there's a couple things not quite working. One thing you'll notice is that they are, we're instantiating it and it's causing the player to move. So there's a couple little problems here that we'll fix. The other thing is it's not moving. So let's just check here on the shot prefab. Maybe give that a little bit higher speed. Try that again. Now it is moving very slowly, so I just have to tweak that number. Now the more important thing is that they're actually, fighting each other. We don't want the shot to destroy the player. So what I'm going to do is actually create some new layers. And so you can create layers. I'm going to come up here. So these are the layers here, and I'm going to add a layer. And one layer we'll call player, and one other layer, let's call it shot, I guess. Right? And so we've got these layers here. Now we can put the player on the player layer, and we can put the shot on the shot layer. Now, just doing that won't actually solve the problem. So it's still going to cause, this sideways movement. What we actually have to do is go into the physics. There's sort of like a physics matrix that we can do. So if I go into the project settings and physics 2D, I can come right down to the bottom. You can see this sort of little collision matrix. And basically it's saying at the moment, everything collides with everything. And so basically we want to get rid of these guys down here because we don't want the player and the shot to interact. We don't really want the player to interact with the player either, so it doesn't really matter. So we'll just sort of turn all those ones off. And now when you go back into Unity and play, you can see that it doesn't cause it to hit. Now the shot's too slow still. I mean, it's got to go up quite a bit here. But you do notice it also, I'm going to go to 100. Again, this could be something you could play with, right? So 100 is looking better. I might even go 200 because usually they go across the screen. That's not bad. I think once we get the asteroids in, you'll get sort of a better feeling there. So I'm going to keep it at 200. Oh, it did stay there. That's good. And yeah, I think we're pretty good with that. Now the next part is, I guess, I'm just sort of thinking here for the moment. I think we're okay. I think we'll just go right ahead and put the asteroids in because then we'll actually have something. Now, sort of surprisingly, the asteroid has one of the more complex scripts here. And the reason for that is because there's just a lot of sort of complexity in terms of making it look a little bit different and so on. So yeah, let's get into it and then we can sort of see. So again, in our sprites here, we have an asteroid. You might as well use the first one. We will put all the other ones in. And the size there, let me just sort of take a little look. I think maybe go a little bit bigger on that. Again, you can play with the numbers. I'm trying to remember here. We might, yeah, we're going to make it smaller if we have to after. So that's okay. Being compared to that, that would be about the larger asteroid. Let's make a asteroid script. There's going to be two scripts that go with the asteroid. One will be the spawner, which we'll get to. This base asteroid one here will be more a little bit about the collision, a little bit about how the the size change, and a few other things that were going to occur here. Okay, so let us put a bunch here at the start. Okay, and so we're going to do public sprite, and this is going to be an array of sprites. So we're going to have multiple ones, and this will allow us to have a bit of individuality to those asteroids. You can see that there was a few different asteroids there. They're all pretty similar, but there are different. And then we have to have an access to the sprite renderer, and we'll call that sprite renderer. That will allow us to change the sprite. And then we just need the rigid body as well, as usual, because we're going to have to give it a little bit of force to get it moving. So RB2D. We will put some variables in here too, and we can change these numbers. So I'm going to type float size equals 1F. So we're going to have this sort of base size, and then we'll take a float. We'll have a min size, and we'll set that to half, and we'll have a max size. And that will be, what did I set here? 2F. So that's what I'm worried about, is that base one might be too big because we're going to double the size of it. So, but we can change that after. Again, these numbers here are just from experience and practicing and testing. So I'm going to put 50F there for the speed, and the explosion speed, which is more like the explosion force, but we'll call it explosion speed. We'll set that to 5. Okay, and yeah, so I think that's good. On awake, so let's just clean this up here, get rid of that, some space. So on awake here, we'll do a few things, the typical stuff. So let us grab our rigid body and our sprite renderer. So let's do the sprite renderer first. Sprite renderer equals, whoops, it was there, get component sprite renderer, looks good. RB2D, get component rigid body 2D. Okay, perfect. Good, good, good. Then at the start, so we're actually going to use the start here as well. So void start. Whoops, I always do that. What we want is to make sure that we can sort of pick a sprite. So what we're going to do is the sprite renderer dot sprite. So that actually grabs the sprite, is going to be set to, and like I said, we have a series of them. So what we're going to do is take from the sprites, we can choose the index value, and we're going to do a random range, random dot range from 0 to the, I think it said it there, sprites dot length. Yeah, there we go. So that will choose, so if we have 4 of them, it will be 0 to 3, and it will choose either 0, 1, 2, or 3, and put a sprite in there. The other thing is, I think this randomly, yep, this one here, we want to start with a random angle about, so this dot transform dot Euler angle. So don't worry too much about this, but this is going to, and it will be a vector 3, not 0, new vector 3. And again, we're going to do 0 and 0. So the y, x and y are zeros. And then we're going to pick a random value, random dot value. So it's going to pick a value between 0 and basically 1. And then we'll just times that by 360. So that will give us a degree there. Okay, so this will just randomly rotate the sprite, so it's not always the same rotation. We're going to do a couple other things here. We have to set the size. So we're going to actually make a little separate function here. So set size. Ooh. Hopefully we can get that in here. So set size, and we're going to pass in the size. And don't worry, it's an error there. We'll come to that in a second. And then rb2d.mass. So you can actually set the mass, and we're going to set that to be the max size. So remember, we're talking about at the very beginning here. Now this set size function, let's actually create it. So void set size, and like I said, it's going to pull in a float called size. And I think we're good. They're good. And it's very simple here. This dot transform dot local scale. So we're just going to affect the scale, and it's going to be a vector 3 dot 1 times the size. So this will actually set, it sets it to 1 basically. It sets it all to 1, and then multiplies all those values by whatever the size is that we're passing in. So if we're passing in the 2 size, right, the maximum, it will make them all full size there. Good, good, good. We're going to create a public void here. Let me just sort of see if I can get that in. Okay, yeah. So next we've got to do here, so I think I can just get rid of this, but I'm going to make this public void, and we'll call this set trajectory. So this will actually get it going. The spawner will actually deal with this. That's why we're making this public. So we're going to make this a vector 2, and then it'll be in a certain direction. And so in here, we want to basically add the force. So rb2d.add force. And that direction will be direction times the speed. And very last here, we'll just get this, we'll destroy. I'm gonna put this in here for the moment, but we're gonna get rid of this once we get the screen wrap going. So we're just gonna destroy the game object. So destroy itself, and then after 10 seconds. But like I said, we will destroy, we'll get rid of this to be removed when screen wrap is working. So we will get rid of that. So now that we've got this trajectory, like I said, that's a public one because we're going to get the asteroid spawner to actually do that. Let us come in and do a little bit about the on collision enter. So when the shot and the asteroid collide, we should have something being destroyed. So let's just see here, on collision, enter 2D. There we go. Oops, that's interesting. Rivet, private. There we go. Okay, so in this one, we're actually going to use a tag. So we have to put this tag on later on, which we'll do. So if the collision dot game object dot compare tag, game object dot compare tag is going to be shot. So we'll do that after. Then we're going to do a couple things here. So if the size, basically, if, just a second, let's just see here. If this, figure out why we've got two, yeah, okay, so that's great. So if this dot size times 0.5f is, so let's say that is greater than or equal to min size. Okay, so the idea here is that we're going to times whatever the size it is at the moment by 0.5, so it's going to make it smaller. And if it's still greater than the min size, then we're going to split it into 2. That's kind of the idea. So that's that there. Do I need one more parenthesis? Oh, I think we're good. Right. And then so what we're going to do is run this create split. And we haven't made this yet, so we have to do that in a second. So we're going to run this function twice because it's going to instantiate 2 asteroids. Okay, we'll see that in a second. And then I guess we're just going to destroy. If it's not the case, we're just going to destroy the game object. Destroy. Okay, good. So I think that's good. Oops, and then game object. I guess we could do this dot game object. There we go. Okay, so let's just sort of create that split one here. So we can make this as a private void, and it is a create split. Okay, so that, what this function will do, like I said, is going to create 2 vectors, or sorry, two asteroids. And so what we need to do here is get the position. So vector 2, it's going to be the position, and basically it's just going to be the current position of the asteroid. So we're just going to grab that, just because when we instantiate, we need to have that. Then what we need to do is we're going to push the position out a little bit. So we're going to modify the position. So the position is going to be plus equals, and this is a little bit different. We're going to take the random inside unit circle. So random dot inside unit circle. This drives a little circle, and what we're going to do is it's going to sort of pick, just a second here, 0.5f. That's just sort of the size of it, basically. It's just going to pick a value. We don't want a very big one here because we just want it very small, so that, but it's just so they're separated a little bit. And so the position here will be, like I said, will be a little bit different. Okay, so it's basically drawing a circle, picking some place in that circle. Okay, and that's going to be the position where we're going to instantiate it. And then, so we have to instantiate it. So we're going to call this asteroid, or from the asteroid, because we have that already. We'll call this one half is equal to, because it's going to be half the size, instantiate what? The same thing. And position, so that's the position we just created, and then transform.rotation. Okay, like I said, this is a little bit longer of a script, and create split. So the size, so the half dot size, so we're going to access the size, is going to be whatever the size is times 0.5f, so that actually changes the size of it. And then we have to get it going. So what we're going to do here is half dot set trajectory. Okay, and the random, we're going to use this random dot inside circle again, inside unit circle, and we're going to dot normalized. So that will just make sure it's set to 1, and then we'll just times that by the explosion speed. Okay, And then I think we're done with that. So the last little bit, I think everything's going well, right? So we had the set trajectory there. We're using it now to give it some force. And like I said, they were just sort of setting it off there in that direction. And the last thing, we need our fixed update again. So I don't know if I got rid of it. Fixed update, there we go. Keep getting rivet here. I don't know. Okay. And so basically this will just, yeah, actually, we don't need this yet. I'm just sort of looking at my code here because this will be part of the screen bounds. Okay, so I think we're good here. We'll leave that private fixed update. This will have to do for the sort of the wrap, screen wrap. We'll have to come back and do that. There's no point right at the moment. All right, so that is a very, very long script, okay? And so we do have, let's put this on the asteroid. And let's label the shot as well while we're at it. So this is my asteroid. And so I'm going to drag that onto there. This is going to, in the end, be a prefab as well. The layer, default layer, I think we're going to need a new layer. Let's just call that asteroid while we're at it. Now, obviously, the asteroid is going to collide with the player and the shot, but it's not going to collide with itself. We don't want it colliding with itself. So I am going to game object, file, project settings, and come down to the physics 2D, because now I've got that layer. So asteroid and asteroid should not connect, but player and asteroid, shot and asteroid should. And the other thing there was let's just go right to the prefab. We need to tag the prefab. So add tag. We made that a capital S on shot. And don't forget that never puts it on there. So let's go back and do that and tag the shot. Now, at the moment, this asteroid here, we've got that. The sprites, so the list is empty. We're going to put in 4. So now we've got the spots for them. So let's just drag those ones in. So in my sprites, I think we're good. I think these are all sprites here. So okay, yeah. Good. So when we get the instantiate, we can be able to instantiate here. Now I think at the moment, let's just see what's going on. It should work somewhat. Give it a second here. There we go. So it's not moving because it doesn't have that trajectory. Let's see if I can fire. Okay, so we didn't seem to have the collision there. There is no rigid body attached to it. So, my bad. What did we not do on this asteroid one here? So, we didn't do anything. Hopefully some of you noticed that. So I'm going to put a box collider on that. I'm also going to shrink that box collider just like I did before. So maybe a 0.8. Okay, and then add the rigid body because it is going to be moving. So it needs to have a rigid body. Oh, I did that again, didn't I? Okay, let's put the rigid body on it again first. Okay, and then let's have that box collider 2D. There we go. And set that back to 0.8. Okay, so that's pretty good. 0.8 might be a little low, but again, you can see what you think. So let's just see if this actually does fire now. Good. Now, you did see it did actually explode, and we might have to play with the numbers there, right? There's a lot of fine tuning that you need to do. But yeah, so when we do hit it, it did move. Now, the trick is at the start to actually get the asteroids to spawn in, and then, we can shoot those. So we're going to do that next. So let's sort of get started on that by going into our scripts and making a new one. And let's call this guy Asteroid Spawner. All right, and so we'll open that one up. And once we get this guy going here, the whole idea is that we need to, like I said, sort of spawn asteroids at the beginning of the game. and then maybe each level as well, depending on how you do this game. And that will be partly up to you. But what I need to do is, and I think at the moment I've just got it spawning kind of all, it's just a one after the other kind of thing, so not in waves. So that would be something that you can kind of get to do to fix. So I'm going to create a spawn rate. And again, I'm going to make that public so that we can modify it easily. Spawn amount. Yeah. Okay. And this guy here, this would be how many, right? You're going to sort of spawn. I can just set that to 1 at the moment. And that's just an integer because it's just a number there. Public float, and this is going to be the trajectory variance. So how much do we want it sort of firing off at different angles? And we'll set that to 15. Again, that's just sort of a number that sort of worked here. We need obviously the asteroid prefab, which we didn't do. So asteroid prefab. We need to prefab that guy. And then last, public float. And this will be the spawn distance. And that's the distance from this circle that we'll create in a second. So we're going to use this unit circle idea again here. So those variables there will be useful. So at the start, we're going to invoke repeating, which means this is sort of not a wave. Okay, it's just going to constantly produce these asteroids. So we're going to do the name of, and we're going to create this function called spawn, which doesn't exist yet. And we're going to invoke it at a certain spawn rate. And just trying to remember spawn rate again. Oh, so the first time and then the repeat time. That's what it is. So we have it does two things. We're going to run this function basically, and we're going to do it after this amount of time and then do it repeatedly. That's what's going on there. So let's just call this one spawn here. And we're going to create a loop here. It's a for loop so that we can do it by the spawn amount. So for int I is equal to 0. So there, spawn amount, that looks pretty good. Let me just double check. So while I is less than the spawn amount and I plus plus, good. So what we need to do, almost like what we had before, we need to figure out a spawn direction. And this will be based on the random dot inside unit circle again. Unit circle times dot normalized, and then times that distance, okay? And I put that big distance, so it's just sort of outside, so spawn distance, outside sort of your game window, basically. And then vector 3 dot spawn point is going to be transform. So this is from the center, basically, position plus the spawn direction that we've randomly created. So that will create a position based on that spawn position or spawn direction, spawn point, float variance. So this will create sort of a positive or negative variance here in the trajectory. So random dot range. So it's going to pick from the negative to the positive version of that trajectory variance that we created. So trajectory, negative trajectory variance to positive trajectory variance. That looks good. And let's see, I think we'll just put this one in here. So some rotation, quaternion, spa and rotation. I can type this in. Yeah. So just finish this up here. Quaternion rotation. I don't know why I've got a is equal to. So we're going to do the quaternion dot. Now this is a little bit beyond us here, but a little angle axis, and then we'll spin it on the z-axis. So again, this just gives us some rotation variation based on the variance, comma, and then vector. So the Z is vector3 dot forward. Forward, if I can spell. Okay, there we go. And then we'll actually instantiate with all these different things here. So we're going to instantiate an asteroid, type asteroid called Asteroid, and it will be an instantiate the prefab. So the asteroid prefab, and I have spelt this wrong, so this instant oops, 8. There we go. That's better. So we're going to instantiate the asteroid prefab at the spawn point with that rotation. Exactly. Okay. So those three things we need: where, what, where, and what rotation. We've got that, and then we're going to set the asteroid size. So asteroid.size. We'll get that to the asteroid because this is at the very beginning. So the asteroid.max size. There we go. And almost last but not least, we have to set that trajectory. So asteroid.set trajectory. And then for that trajectory, we need the rotation again. And then times, I think, times in the negative spawn direction. So just push it back towards the center of the circle. So the spawn direction was positive going out of the circle. Spawn direction is negative going into the circle. And I think that's all we need here. Everything looks good. We've got that still. Let's just clean this up a little bit. Okay, no errors. We should be good. So let's save that, go back into Unity, and see what we can do here. So a couple things is, let's just rename this and make this into a prefab. So assets, I'm just going to call this asteroid. Good. And then I'm going to drag that into my prefabs so that we have our asteroids prefab. Then I think we should create like an asteroid spawner empty. So let's just get rid of this guy here. Game object, we'll create an empty. Make sure it's reset to 0, 0, 0. So reset, oops, reset, there we go. And so I call this the asteroid spawner. And we just add our script there. Asteroid spawner script. And on there, all we need is our asteroid prefab, which is in our prefabs. And in theory, this should work. So let's take a look here. Now, sometimes it's hard to tell. Oh, there we go. So one's coming across. There's another one. And like I said, okay, and so it's working. And you can see it's split. So actually, that's a good little sign there. It's split into 1, split into 2. Now you can see the asteroids are colliding, which is interesting. Ooh, I thought I turned off. Oh, you know what I didn't do? I didn't put them into the asteroid layer. So I did create an asteroid layer, but I didn't assign the layer to that. So now I did that in the prefab. So that should prevent asteroid-asteroid collisions. So I'll have to just double check. Of course, if I shoot them, that will be better. Ah, I think I shot it just before it hit, but it should be working now. So sorry for the squeaky keyboard here. Okay, that breaks that. And you can see they were on top of each other there, and yep, they passed through. So it's not realistic, but that's how asteroids work. The asteroids weren't colliding with each other. So I think it would be worthwhile now to go back to the player and have the player die when it hits the asteroid. So let's go back to our player script and just add a little bit of a on collision enter here. So we did the shooting and stuff, but we didn't deal anything with the collisions. So I'm going to deal with that. So it's just an on collision enter 2D. And yeah, I'm going to have to tag the asteroid too. But if collision dot game object dot compare tag, and then we'll put asteroid as a tag. So what's going to happen here? Well, we're going to we're going to basically reset the velocities here. So RB2D dot velocity. We'll set that to 0. So basically he's not moving. We should also make sure he's not rotating. So let's just do that with the angular drag too. RB2D dot angular drag. Set angular drag. Is that right? I think that's right. Okay, angular velocity basically 0. We'll turn him off. Game object. So the game object set active to false. We'll do that. And then we'll deal with the game manager. So the game manager, which doesn't exist yet, so this is going to look all up and happy, we'll tell the game manager, which doesn't exist, that we should do a deal with the player dying. Okay, and so that doesn't exist at the moment. I'm going to come up here and do the game manager kind of thing. I guess there's no good spot for it, but we'll make that public. Game manager. Again, it will be upset because we don't have a game manager, and that's why it keeps doing that. And there we go. Okay, so what do we need to do next? Well, let us deal with our game manager, because we've got to do a few things with the game manager here. So we'll open a new script. Oops, sorry, I didn't mean to do that. Game manager, let's get rid of that. Those are just my cheat notes there. Bring this back. Do this. Okay. That's better. Okay, so let's go and save this while we're at it, even though there's an error, and go back into Unity and into our scripts. Oh, we didn't tag the asteroid. Let's do that first. Add tag. Before I forget. Save. So let's make well, we're not going to be able to do it because the game manager is there. So we'll check that later, but let's just on our prefab asteroid, and set that asteroid to asteroid. And I think I just want to double check that we did call it asteroid and not asteroids. We should have called it. Yep. Okay, good. And then we'll go and make our game manager while we're at it here. So let's go back into our scripts and our good old friend, the game manager. And we've got that there. Good. So now, okay, it does not complain the player died, so we can't quite test it yet, but let us go in and start working on our game manager here. So the game manager is going to deal with a few things, and one of them is, needs to know who the player is, right? So we'll put that in. So public player. Good. Now we're going to deal with a particle system too. And I can't remember if I made that. I think I did make it, but I might leave it to you. We'll instantiate explosion. I'll just put a basic one in. We can set our lives here. We'll set that to 3. Why do we always get 3 lives? That's always a good question. We're going to have a respawn time. And so part of the problem we're going to have is that when our player is recreated, right, brought back, we don't want it to land on an asteroid, right? We don't want it to get killed by an asteroid right away. So we're going to sort of fix that up. And then so that's going to be part of it. There's going to be a respawn time. So it's going to take time for it to respawn. So it's going to be gone for 3 seconds sort of thing. And then there's going to be this respawn invulnerable or I call it invincible time. And we'll set that also to 3 seconds here for the moment. Good. So the big thing was, what happens when the player dies? Well, there are a few things, right? The lives, we got to go down, right? So the lives will go to, well, go from 3 to 2 for the first thing. And then, of course, if the lives is less than or equal to 0, okay, then we're going to probably have to, I'm going to just put return here for the moment. This is going to be for you. But, oops, we need to do some sort of game over thing. So the moment nothing will sort of happen in the game. It will just sort of return, it won't do anything. But yeah, you're going to have to deal with that, okay? But otherwise, what are we going to do? Well, we're going to have to, recreate our player here. So we're going to invoke, and we'll do this here, the name of, we'll call it respawn. Again, it's going to give us an error here for a second, because we have to do that, respawn, and we're just going to do this once. So this is going to be the respawn time. So how long before the respawn occurs? That's going to be, at the moment, 3 seconds, right? This guy here. We're not repeating it this time, so we don't need that second thing of where it is. But obviously we need the respawn function because we don't have that yet. So let's get that done. It's not too complicated. We don't need update here, so I'm going to do this. We'll call it respawn. And down in here, so this is it needs to know it's going to be the player.transform.position. So we're going to reset its position here, vector 3.0. So set it to the center, most likely. Player. Now this is going to be a little bit different. What we're going to do is we're going to set it to this ignore collisions layer. So what we're going to do is game object dot layer, and we're going to set that layer mask. So layer mask dot name to layer, and we haven't actually created this yet, so it will not be happy, but that's okay. Ignore collisions. So basically we're going to make the player invincible by putting him in a different location, okay? And then we're going to make the player visible. Player dot game object dot set active to true. Okay, good. And we'll also invoke this thing. Invoke name of, and then we're going to create this thing in a second here. Turn on collisions. Okay, that function. So we haven't created that yet, and that's going to run after these many seconds. So the respawn invincible time. Okay. So the last little bit here is that I just have to add void turn on collisions. And so all this will do here is set the collisions on. So, or by changing the layer. So player game object dot layer. So just the reverse of what we did there. So layer mask dot name to layer, and we'll set it back to the player layer. Okay, so I think that's good. So we'll save that. Oop, there's an error there. Player dies is accessible to. Okay, so game manager. We need to make that public. Thank you. Okay, perfect. So I think we're good now. Oh, we got another problem here. Player dies. Not 100% sure what's wrong there. Let's just save this up and we'll come back to that. Yeah, we've got definitely a problem here. So I'll take a look at that in a second. The only thing I want to do is set up that layer as well. So default layers. So what did I call it here? Ignore collisions. And then I just have to make sure, so I don't have to set anything to that, but in my little matrix here, so project settings, physics matrix, ignore collisions would theoretically, oh, just a second, ignore collisions. Yeah, all of these would be like that, right? So it's not going to collide with anything. We don't have to do them all, but just because it does say ignore collisions, we'll do that. Okay. So let's just check this little error here, and it's a very simple error. Oops. So what I need to do is I just put the wrong game manager. I put the reference to the script to the class and not the specific one. So we'll just go back and fix that. And you might have noticed that before. So it just be lowercase game manager, and then that error disappears. So let's just see what we've got. And I think we've got most of this done. Like I said, there's a couple little things that need to be done, like the instantiated an explosion and just, yeah, tinier things like that. But apart from this, the wrap, the screen wrap, I think we're pretty good here. So let's just see how this works. There we go. Okay, so let's just check. And so what we want to check here is that we're actually going to be able to die. So there, okay, we did die. Now I got an error, and probably what happened is we haven't put the game manager in, right? So let's just do that. Create empty, put the game manager in. So reset that. We'll add the script. After doing all that work, we forgot to bring in our game manager. So in our scripts here, game manager, put it on the game object, which I should call game manager. And so we need to know the player. And like I said, we don't have a particle system there at the moment, but that should be okay. You can sort of work on that. Whoops, we want the player on there. And now I've gotten the wrong thing. Sorry. Things are not going well here. Okay, there we go. Player. So that brings in the player there. Like I said, we don't have a particle system, but let's see if we can't get this working reasonably well. I'm starting off on the side here, but that's fine. Okay, so those are exploding with no problem. Okay, now see if, okay, so there I'm gone. 3 seconds before I come back. 1, 2, 3, and I'm not back yet. So I'm still getting this object null reference exception. The player was there. Let's just see here. Was there something else on that? Game manager dies. And let me pause for a second here and try to figure this out. And that was just a second. All I forgot there was that on our player, we have to have a reference to the game manager too. So it didn't know who the game manager was. So let's bring that in. That's the problem when you stop making your game and go have lunch, or dinner actually. You forget what you were doing there. So let's try this again. And so, yep, I just want to get, of course, when you want to get hit by an asteroid, you never do. So, there we go. Okay, so there I've died. 3, no error. Okay, I'm back. Now the trick would be to make sure that I couldn't get hit there. Now 3 seconds have passed, so this would be a little bit. Maybe I have to sort of fire some asteroids. Okay, so I'm gone. Okay, so the ideal would be that I get hit by an asteroid within 3 seconds. Yeah, I'm going to die there. Let's just see again. Come back. Oh, I guess I'm at the end of the game because I have 3, right? So the game over, it didn't work there. So I think that is working, okay? Let's just take a look on the outside, what's going on here. So if we go to the scene view and sort of zoom out, we can see, and you can imagine there's sort of a circle of about 15 units out here, and you can kind of see how they're all being shot in towards this. But of course, then they go shooting off. They do eventually die because we did put a destroy after 10 seconds. And I believe that was the one thing that we said, oh, we might want to fix in the end. And you can see they do disappear at some point. There we go. And so, yeah, what really happens in asteroids is that things are they sort of wrap the screen. So if it comes out one side here, it comes back out the other. So let's get that working. And there is a script, and then we can kind of get that to work on all of them there. So let's just create a new script. And this is a relatively complex script, so you'll have to bear with me here as we run through it. It does have some similarities to the snake game, where we sort of did this boundary. It's going to be sort of similar to that. So I'm going to call it screen bounds, and we'll make that script, open it up. Screen bounds, I don't know what just happened there. Let me just open it again. There we go. And as usual, we're going to create a few variables. So let's just sort of run through this. So public, we're going to take on the camera here. So just call it cam. And we'll also do a box collider box collider and 2D, and we'll call that box collider. So basically that's similar to what we did, like I said, with Snake. We had this box collider on the outside. We're going to use a Unity event, and the event is going to be when we have a... Now, the problem is we have to put in events up here, so let's just see if that gets put in, and that might be the problem. So a collider 2D event, and we'll call it exit trigger fired. And this is giving us an error here because we are not using Unity events. So we're going to go using Unity Engine dot events. And that should, yep, we're okay here. So we'll talk about this when we get to it here. The next thing we also have to have is a little bit of an offset. And this is always a bit of a tricky thing. So I'm going to call this teleport offset. And mostly this is because, so 0.2f, you can't have it, if it goes off the screen and then it reappears off the screen, it would just go back and forth. And so we have to have this little bit of an offset to sort of push it over the edge so that it doesn't, get resent back, get re-teleported back to where it came from. So you'll see this come into play in a minute. And then the corners are a little bit tricky as well. So we do have a corner offset just to handle the corners, and we put that to 1f there. All right, so let's go on to the awake function, just to grab some stuff here. So awake. And so we want to get the cameras basically, well, it's really so this dot cam, because this is going to be on the camera, dot transform dot local scale and equals vector1. So this just sort of centers the camera basically. Okay, so that's just making sure everything's good. We got to grab the box collider. So box collider is equal to get component box collider. That looks good. And the last one there, we're going to set the box collider dot is trigger. We're going to set that to true because we don't want it colliding. So we're actually, oops, Python there, lowercase. That's going to make it sure that it's a trigger. Okay, we could click that, I guess, but we'll sort of do it through code here. And then in the start, so void start, we got the start back. What do we want to do? So we want to set this position just to centered here, position dot, whoops, equals vector3 dot 0 again. And then we want to also, we're going to run a function here, which is update the bounds size. Okay, and again, you'll sort of see some similarities here. So, but what this will do is you could sort of change the camera. You could zoom the camera in or out, and you don't have to go around and play with numbers. Everything would work out. So let's run this. We'll do this update. So this is going to be update bounds size. That should get rid of that error. Good. And then what's going to happen here, again, this is a little bit tricky. So just sort of go with this. So y, we're going to get the y value, and that's going to be the cam.orthographic size times 2. And then the vector 2, so to set the box collider size, is going to be a new vector 2, and then y, so y times cam dot aspect ratio, whoops, cam dot aspect, and then y as well here. So this is basically setting up the boundaries here, right? The vector, the box collider size. Okay, so it's going to let me just think about this for a second. So that takes the y value based on that times 2. Yeah, I have to sort of think about this a little bit more as we go on here. But then box collider dot size equals box collider size. So we're going to update basically the box collider size to whatever we calculated here. Okay. What else do we need to do here? So we need to create, like I said, there's quite a bit of stuff here. We've got to create a public bool. So this is going to register whether true or false, and it's going to be called out of bounds. And it's going to be a vector 3 with the world position. Okay, so it's going to pass in the world position here. Okay, the reason why it's red is we haven't returned anything yet, so don't worry here. So we got a bool. So again, a true or false x bound result equals, and like I said, this is a little bit trickier here. Mathf dot absolute value world position dot x, okay, is greater than, not the teleport opt difference, but mathf dot abs yes world, okay, so this would be box collider dot bounds dot min dot x, okay, minus the corner offset. So this is very long here. I'll just press enter in a second here. So this whole thing, let's see if I can fit this in nicely. So there. I don't know if I can get it much nicer. I'll put an enter there, I guess. So yeah, you can sort of see that. So the Boolean x bound result, so it's going to measure if it's in or out based on if it's the x position and then sort of the greater than the collider here. So if you're beyond that, and then we have to do the same thing for the y. I guess what I could do, let me just press this nicer here. Maybe just set it like this. Press the enter here. There we go. I think, yeah, that basically all fits. Zoom out a little bit or move this over. There we go. Okay, and then the y result, I think I'm going to copy this. Okay, so this is going to be the y-bound result. So just be careful here. Go through this. So world position dot y, box collider min on the y, and then the corner offset. So I think that's good there. And then we have to do another one here. So vector 2, this is going to be the sign world position. So this is if it's positive or negative. Okay, so it's going to return either a positive or a negative here, sort of in the direction. So new vector 2, and then inside here, math, whoops, okay, just a second. I think that's okay. Woo. Okay, just a second here. Let me just bring this over. So new, let me press enter on this so we can see it a bit better. So new vector 2, see if it did this, mathf sign world position dot x, comma, mathf sign world position dot y, and then we end that there. Yep, that's good. Okay, and then we've got a little bit of a comparison here. So if the x-bound and the y-bound result, okay, so if those two, then we're going to have to return a bunch of stuff, and then, so that's if both are true, we'll do this, and then if else, we're going to a little bit more here, so just a second. So the if else here, and so that we've got to say if else, so that was if both of them are true, we're going to do that. If else, we're going to put in the condition here, if the x-bound result is true, so that's that there. If else, x-bound result, I think we're okay. What's going on here? Okay, just a second. And then the other one, I guess just because we don't have anything in there yet, and then this one here, else, what am I doing? Else if, I should say. else if, there we go, sorry. Okay, there we are. And we'll do one more here. Now we got to fill some stuff in still. So I'm just putting in the framework here. Y bound result. And then, so that's that. And then there is an else here. There's lots going on. And then so else. Will return the world position. Okay. Now there's a little bit I messed up at the top here, so I just want to fix that. Okay, return world position. And I think it's just because we got all these things. Else return world position. Sign world position. What I messed up here was, so just a second here. So out of bounds, vector 3 world position. Okay, that's good. What I actually did was I messed up a little bit here. So let's take this. I didn't quite finish this up here, so don't worry. We got lots of problems. So let's fix this here. So out of bounds, what it returns is basically one of two things. So we return, okay, and I'm going to just put this on another line because this is a bit long here. Math f.abs, okay, world position .x is greater than math f.ab dot, again, the ABS, that's the absolute value, is greater than the box collider dot bounds dot min dot x, and then or, and it's basically the same. So I've got the or there, and I think I'm just going to grab this and then just change the x and to y's here. So copy that, paste that in. So this would be y and y. So this is going to basically say if you're beyond the boundary here. Okay, now everything's a mess because I messed up a little bit there. So this should be, for this function, it should be public vector2 calculate wrapped position. So this is actually going to do the xy value. So position, and it's going to take in a vector 2, which is going to be the world position. World position. Okay. Position. Okay. So then I think if I start that bracket, there we go. Okay. Calculate wrapped position. And why is that giving me an error here? Oh, so public vector 2, calculate wrap position. Oh, not okay. So we're just not quite finished here. That's okay. So we did all this, vector, sign, world position. I think we're good. Now we just have to fill in these guys here. Okay, so if the x and the y are true, so basically if it's at the corners in many ways here, so then we will return. This is why it's upset, because not all paths return. So return vector 2 dot scale, okay, world position. So it's taking that world position, vector 2 dot 1 times -1. So it's swapping it, okay, plus, I gotta do a little bit, vector 2 dot scale, again, new vector 2. So we're going to change this up by adding the teleport offset on the x and the teleport offset on the y, comma, and then I think that's right, sign world position. Okay, so that's what's happening if both x and y's occur. Now, if only the x bound result, so if it's just beyond the x, I think, I'll just type this out just to make sure. So return new vector 2, so world position dot x times -1. Okay, so it's swapping that position, And then we keep the y the same, so world position dot y. We don't times it by -1 because we're not affecting that one. Whoops, and then, but we have to also add the offset too. So add on vector2 dot scale, and then basically the teleport offset times sine world position dot x, and then the teleport offset. Okay. So we add that on. All right, and then, oh, we've got some problems here. So just a second. Vector2 scale. So new vector2. Just get rid of that. New vector2. Okay, I think that's set there. Sorry, it's a little, no. Okay, just that. Yes, plus new vector2. Okay, that's good. And then let's just copy this one since this seems okay. Hopefully this will all work out. I think I might just give you this code here because it is a bit of a wild one. So this one's x and then y, so that stays the same, except we're now changing the sign of the y. So get rid of that times -1. And then I think we just have to swap these around here. So teleport offset, so I'll do that. Just get rid of this here. And then teleport off, so sorry, sine. So teleport offset again, yep, times sine world position dot y. Sine world position dot y. Good. Okay. Oh, I got an error. Line 44, we're missing a semicolon. 44. Oh. Return that, that's right. Semicolon there. Okay, so I think that's good. I'm gonna save that there. Okay, so now we've got this huge script. Okay, like I said, and all it's trying to do is figure out who the camera, or where the camera is, and a few other things, and then be able to move those objects. Okay, so let's go back to Unity now, and we'll create another object here. Just give it a second. And so we'll create an empty. This will be our bounds, so we'll call it screen bounds. And then we'll set this to its original spot, and we'll add the box collider 2D. Now that box collider 2D is pretty small there, but I think once we put the script on, we're going to be okay. So I'm going to put the script on there. We need to know who the camera is. So drag the camera in, and let's just see what happens to this box collider. Because I think if everything works out okay, you can see the box collider has become the size of the camera. Okay, so that's taken care of there. Now we don't have any functionality yet with it actually detecting the collisions. We have to add a little bit of script to our different objects here. So let's check with the player first to make sure that the player will work out. Okay, so I'm going to go to the player. Where's our player? That's the one we did originally. And at the very top, I'm going to put in a screen bounds. So just where we, like we did with the game manager, public screen bounds, and then screen bounds. There we go. So that will be a reference to that script, and then we have to sort of check here. So basically, what we need to do is figure out the current position. So I'm going to come down into the update, and I think the fixed update is okay for this. So there's my shoot. Just making sure here. So my shoot function. Okay, so I'm going to come down and put this in here. So what I'm going to do is grab its current position. Just bring this down. So vector 3. So this is just going to grab, like I said, this current position. Current position equals the transform dot position. So that's just keeping a reference to it. And then what we're going to do is we're going to run here. So if, and we're going to grab from the screen bounds dot out of bounds. We're going to run that function based on the current position. So what we're going to do is check to see if we're basically out of bounds. Okay, so if that's true, what we're going to do is set a new position. So vector2 new position, and we're going to run another script on the screen bounds. That's going to be that calculation one. So screen bounds, we're going to calculate the wrapped screen bounds dot calculate wrap position. There it is on the current position. There we go. And then, so that's going to give us the new position. And then, so we're going to do our transform.position is equal to the new position. Otherwise, we'll just keep the current position. So else here, so our transform.position is equal to our current position. Okay, so that will just maintain that position. All right, so I think we're good. Let's just see here. So I've got that. Now on the player, we should have a spot to put our screen bounds in. So let's do that. Then cross our fingers and hope that if we go above the screen, we will wrap to the bottom of the screen. And we did until I died. Okay, that's good. And then, ooh, there, that just proved that goes. And let's check it this way. And that's wrapping as well. Perfect. So everything there is wrapping, okay? And we can basically copy that little bit of script and put it on the asteroid and the shot as well. So let's just see if we can do that quickly. So I'm going to just grab this. And there might be a better way to do this, but I'm going to go into the asteroid here. And we can put this into the fixed update, and that's what I put in there, the screen wrap code. So I'm going to put that in. Now, it doesn't know the screen bounds, so I got to do that as well. So screen, we're going to make this public. Screen bounds. Screen bounds, there we go. So hopefully that does that. And while I'm here, I'll do the shot too. And so the shot, we don't have that in the update, so let's just make it public. Well, it's not public, so fixed update. There we go. And plug that in. And I know why I'm always getting that private problem, but anyways, and then we need that reference to the screen. Good. All right. Now, just sort of thinking here, because these are prefabs, we might have a little bit of an issue. But let's just take a look here. So I'm just going to go back to Unity. Everything's saved. So in my prefabs, let's see if my asteroid. So now it has the screen bounds. Can I drag that in? It doesn't like that. Okay, so let's just deal with that in a second. Great. So yeah, so as I was showing, you can't drag that in. And that's just simply because, I mean, the prefab, you could be putting the prefab into any scene. And so it couldn't be sure which game manager and which screen bounds or whatever that it's looking for here. So what we just have to do is basically get it to find what we're looking for when it's created, basically. Okay, so to do that, probably in the awake is where we'd want to do it. So we'd have to, the player's fine because the player's always going to be in our game. We never destroy it. But a shot is, like I said, it's ephemeral, right? We bring in new shots all the time. We instantiate them, and same with the asteroids. So let's do it with the asteroids first. So on the awake here, we just have to do one line of code. So we have to set the screen bounds, not to new screen bounds. What we have to do is basically find, so game object dot find object of type, and then the type would be the screen bounds. There we go. and then we have to put this, yep, so that's it there. So basically, it's going to go and look for it, okay? So instead of us dragging it in, it's going to have to go and look for it. Same thing, let's just save that. Same thing with the shot, and on the awake, we can do the same thing. And so it will just find that object. So if you ever, don't want to drag it in for whatever reason, you can use this. It doesn't have to be just for things that are prefabs. You could theoretically do it for everything. Okay, so let's take a look at our quote-unquote final game here. Let's see if everything's reasonably working. Let's start our player. It's sad that he's never at center here, so let's just do 0, 0, 0. Okay, there, now he starts in the center. I feel better. All right, so let's see. Now we knew that we flew in. Now what's going to happen here is we're going to get too many asteroids, okay? And we still have, they're going to die. So you're going to have to try to figure out some way of preventing us from having this asteroid festival here, right? You're just going to have too many because they keep moving from spot to spot. So we're going to end up with it. Now they do die after 6, okay? But you can see, right, they're all moving properly. I'm not sure why I'm not coming back. Did I die that many times? Maybe I died that many times already. Yeah, so let's just try that again. So I'll move this time. There we go. Like I said, they're probably moving a little bit too quickly, and there's just too many of them. Now with the shots as well. Yeah, the shots are wrapping, so everything's wrapping. Okay, I come back, that's good. Okay, there I died. Okay, so everything seems to be working out reasonably well. So you have a pretty, I'd say, a reasonable game. The wrapping, I did it a different way before. This is a new way for me, and so I'm still trying to sort of figure it out. Originally, I kind of did it, use a tutorial for this one, so it's a little bit fancier, but I think it's sort of making sense, and we can sort of take a look at that. Like I said, I'd probably give you that code just because it is so long and a little bit arduous there. Lots of places you can make mistakes. Now, obviously the game is, the basic game is there. We've got lots and lots we can add. So you can go onto the Atari arcade there and check out the original version of Asteroids. But there's some basic things that are missing, right? We've got to deal probably with a better way to create some waves. So we've got to think about how we could, we've got this invoke repeating, but maybe we got to sort of do, spawn in 3 asteroids and then, sort of finish that wave and then spawn in so many more asteroids. So we'll have to sort of think about a way to do that. Obviously, we've got to put some sort of score system in. That's always a big thing. And that score system might be based on the size, right? So the bigger, lower point, the higher, more points sort of thing, like the smaller one, sorry, more points. So we could try something with that. Obviously, the lives are working. There's no game over, so that would be something, and you guys are all good at that. But the lives as well, some sort of visible thing. So you might have noticed here on the sprites, there we are. There is a lives one that's a little bit different than that. Now, one thing that's, before I get to that, the sounds, I'll give you the original Atari Asteroid sounds. I've got those. And I've also got, and the particle effects. So this might be something where you can sort of play around with the particle effects a little bit more, because they kind of have a distinctive particle effect when the player dies versus, say, when the asteroids are broken apart. So that might be kind of interesting to implement 2 sort of particle systems. So you might have to do a little bit of research and figure out how to do some nice particle systems there. Talked about the sounds. Oh yes, and the other thing there that we don't have is the UFO. Now I do have a graphic for the UFO. There's usually 2 sizes, a big one and a small one. They're slightly different. I do have the like a file, so I will provide that for you. And you can do a little bit of research how the the UFO moves. Usually it sort of comes in and then firing shots at the player. So it usually would come in from one of the sides, almost move straight across, and then sometimes move at a diagonal. So that might be something. How do you emulate, first of all, when does it spawn, right? Because they don't obviously spawn all at the same time. You can create some sort of logic to control the spawning. And then when it does spawn, how does it navigate the scene, right? Does it go straight across? Does it go across and then move at an angle? And I think that's what I originally created. And you can sort of try to figure that out. And of course with the sounds as well. And anything else you can think of too. I mean, you might have like there was the Asteroids Deluxe, which I think they've got some sort of neat movement. There's sort of UFOs as well, but they're more like spaceships that come after you. So there's a lot of fun stuff that you could do with this game too. So yeah, I think that's probably going to do it for this video. Hopefully you have a game that's reasonably working and that we can sort of take and make your own. Okay, good luck with all your modifications.